Alright, so um, you wouldn't imagine just what happened. I just spent the last 15 or so minutes um, going through the tutorial, and then at the very end, for whatever reason, it crashed, and so it didn't get my second video. So now I have to redo the second video, but I've got all this that I went ahead and did in the second video. So um, don't look at this per se right now. So actually, what I'm going to do is, so I don't waste it, I'm just going to move it for now down here. Um, and I'm going to restart over for you guys, of course, because you obviously didn't hear a single word I said in the second video. So, bam. Alright, so this is where we left off on the first part. And oh man, it was a great video. You guys missed it. I was just having some serious technical difficulties. That one screen thing came up again where it wanted to change my settings, and then it blacked out on me, and then my wife started laughing at me, and then I started laughing, and oh, anyway, sorry, too bad. This will just be a much drier video, I'm sure. But anyway, okay, so basically what we want to do is we want to divide this surface now into a grid. Um, what we're going to do is we're going to go to Surface, Utilities, Divide Surface, into a series of grid points. We're going to do that by connecting this point to this point, and there you go, boom, a grid. It defaults to 10 by 10, which is 10 in the U direction and 10 in the V direction. That's fine for us now. Um, but what I want to show you is I want to show you what the output of this looks like right now. So if I connect this to here, what you're going to see is you're going to see this grouping of, of points. So you've got 11 points, 0 through 10, because it says the number of segments in the U direction. It says 10, but it actually starts with 0, so there's actually 11 total. And then there's 11 groups total, each one separated by this kind of gray bar. So there's group 2, group 3, which it says right there, group 4, and so on all the way to group 11. But for what we need it for right now is not for it to be in groups, in 11 groups. We actually want all the points to be separated, or in some ways compressed. If you imagine those 11 groups as different layers, we actually want to flatten all those layers down into one just giant layer. So what we're going to do is we're going to double click and type in flatten tree. Come on. Flatten. Okay, so a tree is going to come up, and tree, and we're going to connect this value to D. Okay, I apologize for the slow computer is working at right now. It must not like running Grasshopper and Rhino and my video recording software all at the same time. But we'll make do. Okay, so now if I take one of these panels and I attach it, what we should have is, instead of 11 groups of 11, we should have 121 values or points. As you can see, the numbers are getting bigger and bigger and bigger all the way to 121, because 11 times 11 is 121. Then once we do this, we now have everything. All these points are now working independently of each other. isolated in because everything's been flattened. Alright, so now it's time to create our random effect, because what we're going to try to do, I can't remember if I mentioned this in the first part, but we're going to populate this with a series of cylinders that are going to be sizes. So let's go and find the little black kitty, which is over here in sets, sequence, and random, and there she is right there. And what she's going to ask for is, she wants three things. She wants a range, she wants the number of values, and then she wants the seed engine, or the random engine, which is going to feed it random values that are going to just essentially mix up all the points and kind of randomize this grid over here with all kinds of different cylinders. So the first thing we can that we need to do is we need to go over to the list, and we need to find the length of this list. Well, we know it's 121, but the computer doesn't, or the kitty doesn't. So the kitty needs to know the 121 mice that are going to become the tree. Tree length and the list length to the n, and now the random kitty knows how many mice she pull out of her box. Okay. Okay. So now we're going to ask for she's going to ask us for the range. So we have a domain of random numeric ranges. We dealt with ranges in the last tutorial, and then grab domain, and then using provide a range, and let's just type in number slider, NUM number slider, and I think it should default to places, which is going to be perfect. So drag and hit Alt, and then connect those two items, one to there and one to there. And so this is going to be the lower end of the range, and this is going to be the upper end of the range. These two values are going to determine how big the cylinders end up being that are randomized throughout this grid. Next, we're going to do a time check, because I don't want to go over, and we're good. So we're going to connect that to R, and then S is still lacking a random or a seed random engine, so double click, type in slider, and find it, click on it, drag it, and connect it to the kitty. Here, kitty, 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 kitty. Alright, so now values that are determining the sizes of all these cylinders, which we can just forth and back and forth and back and forth to randomize the sizes of the cylinders. And so really the last thing we need to do is drop in a cylinder. So go to surface, primitive, cylinder, and drop it like it's hot right there. Alright, so now what we're going to do is we're going to connect the R, which is going to randomize the radius of these cylinders, and put that right there. And then we're going to